about writing a scientific paper. Now, this is not a 30-minute solution for this problem. It's just an endeavor to open up the forum for a dialogue. Every one of us here has a unique scientific area to address, and of course there is no magic wand to write all kinds of paper in 30 minutes. So if you have something specific about your own paper which you're writing or your own research that you're planning to target, you can stop me and we can discuss that. We have lots of time today. My talk is pretty short, just 20 or 30 minutes, but we have a 2-hour time slot, so probably we can answer lots of questions and discuss things that are of mutual interest. Okay, to begin with, that's a dustbin here. Your writing can take you there, quite simply. You can have an ordinary work, and you can write it well, and you can make an extraordinary paper out of it. That is what I did with my first paper. It was a very simple science, nothing out of the planet. And my postdoc helped me to write it really nicely, and it was published, and so on and so forth. By the way, that if you do that, you end up in the 80% of the published papers. So this is what is going on in the scientific world. If you take 100 papers, 80 papers out of them are just ordinary pieces of work, but they are written to a level that they have been published. That is a fact. However, you can do something else as well. You are Tesla, Nikola Tesla or Einstein, and you have some extraordinary work, and you have the same writing skill as Einstein, and you can end up here. 20% of the rejected papers. He had a very bad writing skill by the way. So, this can happen to most of us, and this can happen to some of us. Both of them result in the same effect. Low quality work or high quality work going into the dustbin. I will show you an example of what I mean. There is this paper, it was published in Cell in year 2000. Whoever wrote it has 15,000 citations to this paper. It is one of the fundamental works on modern cancer biology. The idea is very ordinary. What he has done is just simply listed down what the wet lab scientists have found out about cancer and organized them in a very nice way. And this picture, this figure that I have put here is the world's most cited diagram from that paper. This paper is 13 years old. It was published in year 2000. But as I said, this work is ordinary. He's just banking on the work of other people. It's just that how he has written. And then there is some extraordinary work someone has done in Anderson Research Center, Cancer Research Center in America. And what this guy has done is he has found out a way on how the cancer morphology evolves by using a computer simulation. Now this is not easy, and it's not fast, and probably this work took more than 3 years or 4 years. And the poor guy has just 345 citations. In my opinion, if you read both of these papers, you'll end up saying, this guy was very lucky. But he was not. He wrote it so well that even a guy from mechanical engineering can end up understanding cancer biology quite clearly. But what this guy has done is that he's from my area of research. I had to read this paper at least 20 times to make sense out of what he has done. And when I did, I realized these two things. So you can have a great idea, but if you fail to write it well, it will be of no use to you. So please underline this fact in your research lives. Every one of us during our research careers finds some extraordinary idea, but most of us would fail in achieving the potential of that idea because of our writing skill. So, what we do is, we are young people, 99.9% of us. And what we do is, we have ordinary ideas, and we end up making them look like garbage. And that is 80% of the rejected papers. We have lots of rejections. I'm lucky I didn't have one yet, but I'm sure it feels really bad. So, if you end up having a rejected paper with you, this is exactly what you did. You had an ordinary work, which is fine at this stage of our career. But what you did wrong was that you ended up making it look like garbage. So please don't do that. So this is perfectly fine. The captain has a headache because of that. All of us have it as well. So how to move on? What we think, our initial impression about writing a paper is that I know my research is the best in the world. Yeah, there is this God-given confidence in every one of us. We think Einstein would have been proud of us had he been here. And that I can write it really, really well. I can convince the researcher without even his first review. But that's just the pep talk, the lip service. And when you combine that, you end up looking like this. Superhero. However, of course, we end up doing things very fast, writing it up, and thinking there will be no problem with our publication. But very soon you realize that my research is naive. It's just basic research towards any topic. And I have never written a complete paper myself alone in my whole life. And the people, the reviewers, can understand and cut into my work very, very fast. And we realize that once we read the reviewers' comments, that this guy has actually understood my work more than I ever imagined, or even my own understanding of the work. Now this is trouble, big trouble. That is what that superhero looks like after you get the review. And so what is the realization? I need to write well, really well, so that my ordinary work, my initial footsteps in the research world, they get published. So you better get down to work. Yeah, and it's pretty serious. It's pretty serious. The perception about writing when you sit down to write is like this. Everything is neat, your desk is clean, all the 500 papers that you have studied have been thrown into the dustbin, your desktop is shiny, you're writing your draft, but the perception is wrong again. So what does it look like, this writing process and the submission? This is what it looks like. Of course, most of us have more hair, and we end up facing challenges from all kinds of people. Some of them may be from a different area of research than what we are trying to do, and they would be looking at our work in a very unique way, and we need to satisfy their questions in order to get published. Now that's not a joke. You are asking a biologist to evaluate something from the mathematical side or the differential equation modeling, and you have to satisfy him that the mathematics is strong enough to actually abstract the real biological phenomena. That is pretty difficult. So you have to beat all of these people on your way, and at the end, you have a published, or what is it, accepted paper? Yeah, accepted paper. Most of us, we get gutted in the way and give up on our paper. So what to do? How to go about it? The foremost important thing that I have failed to learn myself as well, even though both of my postdocs and my professor and my colleagues, they emphasize it all the time when we have our meeting, is the logic of the paper. No one is interested in looking at how many sleepless nights you had in your lab. No one has the time. No one is interested in how long your simulation process or how long your wet lab experiment took. They don't have the time for that. What they are interested in is What is your finding? And how do you report that? By developing a strong logic in your paper. What we do as young people is, we're actually foot worshipping the reviewers and begging them by stating long stories of our work, which have no practical implication for the publication process. And that, if I am a reviewer of that paper, I will probably reject it straight up, because the author has no idea how to organize his work. I will tell you the story of a paper from a very big lab. There is a cancer modeling lab in MIT. They sent a paper to my professor for review. They submitted to some journal, and that journal forwarded it to a professor. And the professor sent it to my postdoc, and the postdoc sent it to me. Yeah, it's like, anyway. So when I read that paper, I thought, this guy is looking for some government fundings. And the reason why I thought like that was, the paper was ill-organized, the journal was big, he was using just the name of his lab, yeah, publish me. It was saying like that, just publish me. But the logic was so poor that even a student like me, who has never had any practical experience, found it out quite straightforward. And I wrote the review for my professor, and my professor said that next time you write your own paper, you think of the reviewers as having the same point of view as you did to this paper. That is very important. If you do not have a logic in your draft, in your manuscript, it's of no use, right? And this is 80% of the paper, without even writing a single word in your manuscript. You take my word on that. So what you do is, to develop your logic, you have to organize your work. Here, you did 500 experiments, fine, 400 of them ended up having artifacts, no point in them. So you get rid of that data, you trim your data of the remaining experiments, and you write it down. And then you write the evidences and the results in a nice way, the ones you want to use in your paper. Yeah, you must change your mindset from the perspective of an experimental scientist to a writer. This change of the mode in the way of thinking is absolutely essential. So you have here 100 evidences that you ended up after you trimmed your data and whatever. But which one of them to write? Yeah. You choose the one which is the most defendable argument. It doesn't have to be exceptional results which you cannot defend, which you cannot explain. You keep that for your next publication. But you put up with data that you can defend clearly and strongly. It doesn't have to be perfect. It doesn't have to be that way. So now you know what to write one experiment. But how to write it? There are 100 ways. So let's see how the contents of the manuscript they develop. As all of us know about the introduction section. The first, these are 6 points that you can just copy paste from this presentation. Probably they will share it on the Facebook. And you can just copy paste these 6 points into your paper, and you can start answering them one by one. And then let's take a look at these points. The first one is, what is the background or literature review? These days I'm writing a manuscript, and I sent that to my postdoc, and he got very angry, and he came to me and he said, Safi, what do you think, the reviewer is an idiot? So you don't have to tell the reviewer how Adam was born and how Hawa came and how the world was born before the science was discovered, and then you ended up in KAIST, and then how you found out this research area, and then you did this experiment, and there was a eureka, and you discovered something fantastic. It doesn't have to be that. This is about literature review. You have to find the entry point into the literature. that is not too far, and that is not too close to your research. If it's too specific, it's not an introduction, it's a discussion. And if it's too general, you shouldn't be writing a scientific paper, you should write a novel. So there is a slight difference between them. You have to optimize at the entry point in your introduction section. The abstract, after the abstract, the introduction section is going to determine the probability of your paper's acceptance. It is not your results section. Most of us, we say, oh, I'm not getting my results right. There is some problem with the experiment. Oh, the curve isn't going up as it should. That does matter, but it's less than 15% or 10% of your paper's acceptability criteria. What matters the most is the abstract and the introduction section. And in the introduction, this first point is what the reviewer will read when he's going to open your manuscript. And if you start by Adam and Eve, you will end up in hell probably, rejected quite quickly. Second, you must clearly, absolutely clearly write down what is your specific scientific question. Exactly. If the reviewer is not going to find out what this guy is writing, how is he going to write a review? Yeah. Sometimes we write so much in the introduction that we end up losing our focus from the main question. The introduction is supposed to introduce the question, the purpose of the paper, right? So you must absolutely clearly state, in this work, we plan to investigate the effects of ROS on the metastasis in cancer, or something like that. You must clearly state. And if you yourself are not sure where your question has been stated in the introduction section, forget about the reviewer being able to find it out. And if he doesn't, reject it. Thirdly, you have to justify after you state your question, why is there a need to answer this question? I mean, why, after all, should the scientific community be publishing your manuscripts and the community of researchers be reading them if there is no need for your work? So, after you state your question, you must come to justifying why you need to answer this question. It is the second most important thing in the introduction section after stating your question. And then it gets easier after that. What did you do to answer this question? It depends on your area of research. Some people do some wet lab experiments. I do computer simulations. Some other people, they do some mathematics. Some other people, they apply some kind of other methodologies. And then simply, you state your results. You can take this note. The size of the results inside the introduction section, it should be in a ratio of 100 to 70 as compared to the abstract. If you're writing 70 words for results in the abstract, you should be writing 100 words for the results in your introduction, and not more. We tend to be a little bit more energetic about our results in the introduction section, and what we do as a result of that emphasis is we bog the reviewer down instead of being able to tell him the whole story. Because after you mention your results, you have to conclude the introduction. The explanation of the results can go into the results section. You will have a lot of opportunity to explain and go in depth with figures and diagrams about your results. But please don't do that in your introduction section. Ideally, in the introduction section, there shouldn't be any figure, ideally. Unless if you have an absolute necessity, especially if you have done some literature review and you would like to put them in a collage and show to the reviewer that this is the state of the art, maybe you can add a figure. Maybe. I think it shouldn't be there. Anyway, so this is for the introduction section. You can just copy paste these things into your Word file or LaTeX, and then one by one you can start answering these questions. I will talk about how to answer these questions later as well. Okay, about the results. There is a very subtle way of writing the results section. I think most of us already know it, but anyway, just for those who are not sure. the result section is not the introduction section, of course. Sometimes we start to write our result section like this. There is this scientific problem that we were trying to solve. And to solve that, we did this, and we did that. But that's not results. You have to be straight about the results. We found out that stress on the epithelial cells results in their detachment from the epithelium lumen, something like that. Straight to the point. This is not introduction. You're not supposed to introduce your work here. You're supposed to report your result. And the more direct you are, the more chances you are creating for acceptance. You have to be absolutely direct. Okay? Now, whatever your results are, whatever your area of research is, you can start like this. You remember we talked about stating our problem in the introduction section. Right there. This was the most important thing in the introduction section. Your main question. You have to start this result section by answering that question here. What is your answer to the initial question, Q1, that you mentioned in the introduction section? You don't have to tell all the questions you answer in this research in the introduction. You just have to state the main question that will initiate the inquiry of the reviewer. That's all. Here, you answer that question, and then you look at what new question did that. Okay. For example, in one of my works, I found out that the cells, if they don't have enough ATP, they continue to live and they don't die. So I thought, why does it happen? So what I did was, I went to my second result. I said, to answer this question, I looked at the cells which had their ATP depleted, and I tried to look at their mode of cell death. And when I did that, I found out that they were actually starving in hypoxic or hypoglycemic conditions. But anyway, from the first question, you have to relate your second question. You can't talk like this. The horse cart had a broken wheel and then the locomotive engine needed an oil change. It's not going to work. It has to be smooth. It has to be smooth. If it's not smooth and if the reviewer is not happy, what you're doing is reducing your chances of acceptance. Do not ever compromise on getting your chances of acceptance reduced, let alone minimized. Okay, this design pattern can be repeated over and over and over again. So from the second question here, we found out that lack of oxygen causes hypoxia in the cells. In order to find out how much hypoxia was serious, we performed another study. Yeah? So you have to relate one result to another, second to the third, and so on and so forth. If you are able to do that, I think you are through. No one reads the discussion and conclusion officially. Yeah. Okay, let's go on. The methods and materials, it's so variable, there is no point in discussing them. But just another mention of the entry point, as I mentioned in the introduction section, you don't have to start from the formation of the world to introduce your study. And similarly for the methods and materials, the entry point is very important. You have to be very direct here. Just go on to introduce your equipment. Yeah? For example, we use the NTR architecture to construct the basic framework of the code base, or electron capture dissociation was used to ionize the proteins using blah, blah, blah. We use 500 ml of sulfuric acid to do something. You can just go to your equipment, your chemicals, your methodologies, your methods, and just write about them. Finished. No need to link it with the introduction. It has got nothing to do with the introduction section. It has got nothing to do with the results section. It has got nothing to do with the discussion session. It's just standing out there for people who would like to replicate your research results. And it should serve just that purpose, nothing else. And it's not going to play any part. In one of my papers during my MS, I made some mistake. in this section, and the reviewer didn't even look at it. And we found it out after we got the review, and we fixed it. But anyway, the point is that it's not important. It will not increase the chances of your acceptance, except 5% of the papers in which you are using some. For example, if you're working on nanoscience materials or something like that, then it may become a little bit more important. But otherwise, it doesn't really matter. But what is important is the directness of the entry point. And then discussion section. It is probably written on a similar pattern as is the introduction section. But then what's the difference between the two? In the discussion section, you don't elaborate on the background that much. You just write shortly about the background, and your results in the introduction section, which were just a little bit longer than your result in the abstract, you make them reduced further. And then what you do is you go to the contrary findings, the conflicting results that have been reported by people, looking at the shortcomings of your own work. And yeah, why should your shortcomings be tolerated? Yeah, it's a discussion. This section will never cause in the rejection of your work, but it may cause towards increasing the chances of the acceptance of your work. If you can fight for your work, do it here. Don't do it in the results section. In the results, be absolutely accurate. No need to fight for your argument in the results section. No need to fight for it in the introduction section. If you want to do it here. Yeah, don't beg the reviewer in any section except this section for acceptance. And then there is a conclusion, which is quite simple. What has your work contributed to science? We have invented something, we have invented something, we have reported something. This will lead to the emancipation of mankind, something like that. Yeah, and how can this work be expanded? Sometimes people are interested in this because the reviewer has a deep understanding of that work, and he's interested in looking at how this work can be furthered. So it is important sometimes. Anyway, this was the boring part. So, how to get into the manuscript? There are some very important things you must do. I made many mistakes during my last 4 years, and of course we should learn from them. Otherwise, there is no point in making the mistakes. One thing that you must do is to have a presentation that summarizes each paper you write. Every paper, every manuscript must have a corresponding PowerPoint presentation with you that is ready with you, that you can use to explain your paper, not your research. Everybody has a 200-slide research presentation, but very few people make a presentation in which they're going to talk about their paper only. And this is very important because it will help you to do the 80% of the work. That was the logic of your paper. You can develop your logic in this presentation. You can show it to your colleagues, your brothers and sisters. You can ask them, okay, I would like your views on this. There is no harm in this. And they can say, well, there is a jump here, there is something missing here, it doesn't make sense, you are crazy. You can listen to all kinds of comments from people, just write them down and fix your presentation for the paper. And in that PPT, you can just follow the same format as you do for the paper. Just make an introduction in section, 4 or 5 slides. You can break them down according to the 6 points I mentioned in the first slide about introduction. And you can elaborate each section with the text, figures, and references. You know, most of us, when we start writing the paper, we ignore the references. It happened with me so many times that I'm tired of it, my own mistake. I found some very interesting paper. There are some very nice results. I say, oh, this will help me in defending that point. And then I go out to make a cup of coffee for me, and when I come back, I have forgotten which paper was that. This presentation is where you should always register your references for every figure. Even if it becomes 500 references, it doesn't matter. Now we have very nice softwares. You can use EndNote and Mendeley, and there's so many other tools. So you can just add a reference, yeah? Reference 5, 6, you just click on it and go into the Mendeley and open the PDF. You don't have to manage anything. So don't lose your references, because if there is a point in your manuscript which is not clear to the reviewer and you have put a reference in front of that, he will immediately open that reference and he will check that reference in order to understand your writing. And if your reference is there, if it's a good one, if it's a big journal, yeah, always get references from big journals. Don't get them from cheap stock. It will not help you. Yeah, go for Science, Cell, Nature, PNAS, MSB, whatever your IEEE or something like that. Always go for that, because if I am the reviewer, if I say, oh, this guy has given the reference from Cell, it must be good. Yeah, most of the times I won't even open it. That is intellectual dishonesty, but anyway, that works here. So keep your references and keep good references. And of course, you can develop your figures here, and later you can move them to your manuscript. And lastly, always version your manuscript. You know, sometimes we edit something in the paper, and you can't undo that. It's lost. Every day, I make a new version of my paper, just to reduce the probability of losing some important text, piece of text, some word, some specific expression, just to keep myself safe. Don't ever write manuscript in one paper for 3 months. Don't do that. You will appreciate the value of my advice once you lose your work. I hope you don't, but if you do, you will remember this day. Okay, so how to develop? You can manage the manuscript now. So how to develop? Some people do this. They start writing with the title of the manuscript, then they write their name. First author, okay, good. Second author, third author, and by the time you reach the name of your professor, your mood has already gone down. And then you start abstract. Okay, what is my abstract? This approach will never work. The abstract is supposed to be written, anyone. Can anyone tell me when is the abstract supposed to be written? And what's your opinion on this? Anyone?
The end of the paper.
End of the paper. Anyone disagrees with Brother Rahul? Who has never written a paper?
Never.
And who has written a paper? Why your hands are like this? your results are not forged, right? So what do you think, when should we write the abstract? No, of course, not the position. Not the position. I mean, at what time? At what time during the manuscript development should you write the abstract?
Yes.
After finishing your manuscript,
right.
Then you should write that.
Okay, so two brothers, they have the same opinion. Anyone disagrees with this? No one disagrees. But let me ask, not these two, because none of us disagrees. Let me ask you.
I disagree.
You disagree. Why do you disagree?
After developing the idea, then you can just write down the rough abstract.
No, not the rough abstract. I'm talking about your manuscript.
That comes always in the end.
Okay, so no one disagrees with this, but then a question comes to mind. Why at the end? Not you three. The other people who don't disagree should answer this question. Why should we write the abstract once the manuscript is finished? Why?
Because the abstract of the manuscript, so we should have in the end, like we have the introduction, we have the result, so we can abstract it everything in one, like 100 words, something like this.
You mean the manuscript is developed,
yeah.
So now we are in a better position to write the abstract?
Yes.
Silent.
I think you have, at that time, you have everything. You have written the whole story.
Well
So
said.
you can easily
Focus on the important things.
Important.
This is absolutely right. Never start with the title of your paper and the first author and the last author and the abstract. Okay, here we go. No, this is not the way. You leave that space empty and you move to the introduction. And once you are there, what you do is, You just write bulleted fragments for each content item. You already have those content items in the introduction section, 6 of them. You just write words, phrases to elaborate. You have a bulleted list of those items. You don't have to write full sentences. Once you do that, you are in a position to better organize your logic. At that time, if you are focusing on writing proper English in a nice way, you will not be able to focus on the logic. First, you have to focus and develop your logic for the manuscript. It is 80% of your paper. You can't fail in that. So if you do that well, you can nicely elaborate each bulleted text into nice paragraphs later on. Okay? So do not focus on writing pretty English, exhibiting your school English. Never try to do that. Just write small points, organize your logic, focus on the logic. By the way, I learned this from the Korean people. You know, they write papers in Korean. It's amazing. They start their manuscript by writing the whole thing in Korean. I couldn't believe that until I saw my postdoc's paper. So I asked him, why you write it in Korean? You waste so much time. It takes a month just to write that thing in Korean, and then you're sitting and looking at dictionary to translate. So his answer was, it only stressed my previous thoughts, and that is, he said that if I am able to develop a strong logic, I have won the acceptance. And right, that's 80% of the paper. You can write it in Pashto, in Urdu, in Indonesian, in Malay, in whatever you can write it in your baby language. Yeah, but you better get it right, the logic. Once it is done, you can translate. You can seek the help of someone who can sit with you and just organize your thoughts well. This is important. And of course, once you do that, you can elaborate each fragment with one-liners. And each line which you write, each full sentence you write, you can later expand into a paragraph. That is what I do. I write the bulleted segments of my thought, organize them, I replace them with one-liners, and then for every one-liner, it takes me 1 week to go through each section, and then I replace it with a paragraph, I organize it well, and once you have done that and you read your own paper, it gives you satisfaction. Yeah, it gives you happiness. I did well. And once your professor will read that, he will still not appreciate you, but anyway, he will not be angry with you. Right? Okay. Finally, since most of us are sleeping, some useful tips. I don't know if it will happen with you or not, but with me, my lab chair is very boring. I just can't think of anything else when I sit on that chair except my paper. I don't know why, but anyway. And that can fix you into a thought pattern. You cannot change your perspective while sitting on that desk, in that position, in that chair, with those books and figures are all around, patched all around your landscape. You can't escape it, and that is monotonous. It doesn't let you cross-examine your own manuscript. So what I do is, I take a printout when I'm writing a manuscript. I take it to my dormitory or room, wherever. And before sleeping, I take a deep, long look at my paper. And I absolutely make it all red. No mercy for your writing. Yeah, it's not, you are the reviewer at that time. And you can absolutely take it apart. This is nonsense. Sometimes I write, this jump seems, there is a break here. This explanation is not sufficient. It doesn't justify your answer. I talk to myself, I write it down. And once I reach my chair back in the lab, I'm looking at those comments which I wrote last night, and I'm thinking, oh, how am I going to answer these questions? But if you do that, your reviewer won't be doing that to you. So it is absolutely important to change the perspective which you take on your manuscript. What I do is just go out. Sometimes I go to the river to read my books. You find out how you can change your perspective on your manuscript. I don't care how it happens, but it must happen. You will realize the meaning of this point once you examine your own manuscript in a changed environment. And you will say, oh, what was I eating when I wrote that? Secondly, work loss. Use this thing, Dropbox. It is very nice. I lost a disk. I lost my papers. This is serious. And you can't justify that in front of your professor, yeah? He'll never understand. It's as if he doesn't understand anything. So what should you, I mean, how can you do this thing without spending a single joule of energy? Just use Dropbox, yeah? Keep your papers in the Dropbox, edit it from there. It will automatically save and version everything alphabet by alphabet. So you never have to worry, oh, my disk died or something happened or lightning struck KAIST or something like that. You will be in peace. You can sleep well. Thirdly, I had a very harsh time. I don't have a very nice sense of colors. And once I make a figure, I get thrashed by my postdoc for making that figure. But anyway, you can use high resolution images in your papers, whatever nice drawing you make by using this file format. It's called EMF, Enhanced Meta File Format. It's the highest resolution that you can get for small size 1 MB files for images. It's so nice, I love it. It's fantastic. My postdoc told this to me, and I'm still very thankful to him for this. So you just go to this software. Oh, sorry, it's not Vision.
Visual.
It's Visual. You go to Visual and you use this format. Usually the journals, they have a requirement of 300 by 300 dpi, dots per square inch, minimum requirement for the resolution. If you set your visual setting to that, you don't have to worry about it later. It will automatically start the software in that configuration. You just save your file, reduce your headache, reduce your hair loss, especially the sisters. Yeah, it's very nice. Okay, next one. The small size videos. So what I do is, I have some simulated, I record my simulations as videos. And I have to provide them to the journal as evidence for my simulation. But the videos which I have, my simulation is running for 2 months. A movie which runs for 3 hours is usually what, 1 gigabyte or something? Imagine if you have a simulation that is running for months. How would you make a video out of it? This used to be my nemesis, yeah? I used to cut and paste and remove the frames, compress the frames, spend days on compressing the videos, and my professor would say, it's a 45-minute video. No reviewer would like to view your 45-minute movie in which a cell is just moving here and there. So what to do? It's serious headache. But then, luckily I found this software. One of my friends, he's a postdoc in Japan, he works on the 3D animation, so those guys have use for this frequently. So he recommended this to me, and it's fantastic. It's called Free Make Video Converter. You can clip the videos just by clicking, and that's all. All headaches are removed. It's better than Panadol. So you use this. And then literature references, you can use EndNote, or you can use, anyway, I think LaTeX. How many of you use LaTeX? No one. Okay, just one brother, 2 brothers. So anyway, you can use EndNote. You know, if you add some reference in the 4th story and then you have to change everything in your paper, it's not easy. So you just install the Microsoft Word add-on for EndNote, and it is so easy. You actually reduce your headache again. You don't have to manage your references. and that is probably the best. There is a new version, yeah, it's this it's called X6. So if you use this version, you just click update manuscript and it will organize, sort the references according to journal formats. If you want to submit it to bioinformatics, you just go to that EndNote setting, and there are, I think, more than 1,000 journals. You just select that journal, and it will automatically format all of your references according to that. Not a single mistake in the comma or dot or initials or last names, just perfect. So don't forget that. And by the way, if your journal is not listed in EndNote, you go to the website of that journal and you download the EndNote, it's .ena like file. You just download that from the journal, you go to your EndNote installation, you load that plugin, and you're ready to go. So that's all, I think. Thank you. Questions and answers.